Hi, my name's Renee Morales.
Hi, my name's Kitia.
Hi, my name's Anna.
Hi, my name is Alanis Vargas.
Hi, my name's Marisol.
And this is our rocket project. We made a project in December at Southwest High School to deepen our knowledge in physics.
We decided to use the Side Guys video on how to build a water bottle rocket because we thought it was a really simple way to build a rocket, and we kind of liked how high it went, and we liked how they explained things in the video that we could use for our project.
What are you looking at, Alanis?
Right now I'm looking at the water rocket, and I'm going to look at the frequently asked questions because we have a lot of questions. And I'm going to go down. And one of the questions I wanted to look at was over here, which is the best shape for our fins. And this is kind of what we want for our model, but we're not sure yet. We're gonna pick it later.
What are you looking at?
I'm looking at this website from NASA, and it gives you like instructions how to build a water rocket, and it's actually not that bad. I thought it was gonna be harder, but it's not.
We have decided to use this website for our rocket project because it gives us a lot of insight on how to do the water rocket, and also it has just a lot of advice. What are you looking at, Marisol?
I'm on WikiHow, and it's like I'm looking about how to like build a rocket. It tells me in like depth how I can like create one method of a rocket, and then it also explains how we can like two different other ways that we can launch it in order to get like a bigger success. For our rocket project, we're going to use soda bottles, a hot glue gun, a tennis ball, 2 corks, a nail, a utility knife, some tape, a ruler, and some cardboard.
Construction phase. For our project, we decided to decorate a rocket as a Christmas tree. To start off, we painted the wings and bottle green, then added ribbon. We also added small furry ornaments to our rocket. Lastly, we painted the wings with red slash. We decided to hot glue the ribbon onto the bottle in order for it to look more clean. However, when we attempted to hot glue the wings to the bottle, we realized that the glue made the bottle melt. Therefore, we had to tape the wings to the bottle. We added wings because without them, our rocket would not fly straight. While taping the wings to the bottle, we realized that the clear tape was not strong enough to hold the wings stable. As a result, we switched our tape choice to duct tape. At the top of our rocket, we placed the tennis ball. Using duct tape, we taped the tennis ball to the top to keep it stable. The tennis ball serves many purposes to our rocket. The tennis ball helps reduce air drag by streamlining the air as it flows past the surface of the rocket. It also adds weight to help move the center of the mass towards the top of the rocket. Since the hot glue gun wouldn't help us stick our wings to the bottle, we had to use duct tape. We also used duct tape in order to tape the tennis ball to our rocket bottle.
Alright guys, what day is it today?
Day one.
Launch day.
Oh, launch day.
Launch day, day 1. We're missing Kitia.
We're ready to launch our rocket. We're about to go. Woo! We realized a phenomenon where a trail of water is after the rocket when it is launched. The water moves at a high speed and continues at a constant speed. Since there is no air coming in from our rocket, we were able to fly straight, but it was lopsided since our wings were unstable and crooked. We used resources on YouTube to help us use the program, which was the video tractor analysis.
In order to obtain the data from our video, we used tracker video analysis. In order to get the most accurate data, we inputted our rocket mass, which was 135 grams, and how tall the tower was, which was 5.6 meters. The graph shows how the course of the rocket during its launch. Each red point represents each frame that we tracked. And our table here gives us the data of our time, x and y values, velocity, acceleration, kinetic energy, frame, and momentum.
To find the rocket's mass, we use this formula, which is our known mass and known distance equals rocket mass and rocket distance. And we plugged in what we knew to the formula, which was the 150 kilograms from the weights, and the distance how far it was from the pivot. And then we put the distance of how far a rocket was from the pivot. Then we just canceled it out to get the unknown by itself, and we got a 135 gram mass.
As seen in the video, the rocket we calculated the mass is not ours. We measured a similar rocket because the one we made was destroyed in the launch. To measure the rocket, we used the equilibrium of torques method. The equilibrium of torques method is when you calculate the unknown mass of an object by placing it on a known distance on a surface, then balancing it with a known distance and mass on the other side. We tie the pivot to the meter stick using string. Before placing the rocket, we needed to balance the stick on its own. At 50.3 was a center point where the meter stick was balanced on its own. We also used string to tie the weights at one end and to tie the rocket at the other end. We began with a weight of 50 kilograms at 10 centimeters away from the pivot and placed our rocket 10 centimeters away from the pivot on the other side. It did not balance. After many attempts, the meter stick was balanced with our rocket at 30 centimeters away from the pivot, and on the other side, the weight of 150 kilograms at 27 centimeters away from the pivot.
Something that we learned was how to calculate the mass of an object using the torque method, and this included using a balancing scale to find an unknown mass.
Some mistakes that we made during our process of making the rocket were that we threw our rocket away, which we needed to find out the mass of the rocket, and we also took the video of the rocket launching at an angle that it didn't work for the tracker video analysis.
One advice that we would give you guys is to keep your rocket simple and don't go overboard.
And if we do this again, we would take a video of the rocket launching at a horizontal view.
Okay, 3, 2, 1. And this is our rocket. I was gonna say.
Project using the torque method, which included how to wait. Wait, no. Okay, can I go?
Yeah.
Okay, 3, 2, 1. And this is our rocket project. Got it. Yay.